Welcome and welcome back to Arinze Easy Maths. Here we are studying bearing and distance. Examples: given that y is 20 meters on a bearing of 300 degrees from x, how far south of y is x? Option A 10 meter, option B 15 meter, option C 25 meter, and option D 30 meter. Let's start. Solution. The first step is to draw this on a diagram. Draw your 4 cardinal points. This 4 cardinal point is for x because bearing y is located from x on a bearing of 300 degrees. This is my point x. So 300 degrees here will be on the fourth quadrant because 300 degrees can be calculated using this method. From here to here is 90 degrees. This is another 90, making it 180. This is another 90, making it 270, still less than 300. So when I add extra 30 degrees from the fourth quadrant, I'll get 300. So it will lie on the fourth quadrant. You draw a straight line from the fourth quadrant to locate your y. This point now will be my point y. Draw your 4 cardinal points there also. This is my point y. So from here round to this straight line is 300 degrees, but only this place alone should be 30 degrees. That is because 270 plus 30 is 300 degrees, and the distance is 20 meter. The point itself is point y. This point is point y. So we are asked how far south of y is x. Remember, this is north south, so here also is north south. This is south of y. Tracing the south of y down straightwards to meet with point the point to meet with east of y x, I'll form a right angled triangle. So this is a right angled triangle. This bearing is a problem of a right angled triangle. This is, let me draw the shape here. So the angle here is 30 degrees. The hypotenuse is 20 meter. This is right angle, and I'm looking for this point. That's the point I'm looking for because that is the south of y. How far south of y is x? Okay, we are going to use SOHCAHTOA to estimate this. Okay, SOHCAHTOA. S stands for sine, O stands for opposite, H stands for hypotenuse. C stands for cos, A stands for adjacent, H stands for hypotenuse. T stands for tan, O stands for opposite, A stands for adjacent. In this my diagram, I have an angle, a side opposite to the angle, and hypotenuse given. So I will use the first 3 letters here. Sine, so that is sine equals to opposite over hypotenuse. So sine 30 degrees is equals to opposite, which is x, over hypotenuse, which is 20 meter. So when I cross multiply, I will have that 1 times x will give me x, which is equals to 20 times sine 30 degrees. But sine 30 degrees is half. Therefore, this means that x is equals to 20 times half, 0.5. 20 times 0.5 is equals to 10 meter. So my right answer here is option A. 10 meter is the answer. Okay, number two. Number two says this diagram shows the position of three ships A, B, and C. A, B, and C at sea. B is due north of C. B is due north of C. That means B is directly on the north of C. Such that AB is equals to BC. This length is equals to this length. And the bearing of B from A is 40 degrees. What is the bearing of A from C? That means we have to estimate the angle from here round to the line joining A and C. That's our task. Of course, from here to here is 180. It's known. So our job is to find the remaining. The job would be rather to find this angle, and when we get it, we subtract it from 360. Let me call it theta. When we get this theta, we take it away from 360, and that will be the bearing, because when you add this and that theta, it will be equals to 360 angle at a point. Okay, looking at this line and this line are parallel line because they are not poles. They are not pole. This is not pole of A, this is not pole of B. So this is alternate to this. This angle must be alternate to this angle. Beautiful. Now looking at this triangle, this is an isosceles triangle since two sides are equal. Therefore, if here is theta, here also must be theta, because base angle of isosceles triangle are equal. This angle and this angle must be equal. So from this theorem of sum of angles in a triangle, these angles must sum up to 180 degrees. That's 40 plus theta must be equals to 180 degrees. Reason, sum of angles in a triangle is always equals to 180 degrees. So this then means that 40 plus 2 theta is equals to 180 degrees. This means that 2 theta must be equals to 180 minus 40, and that's equals to 140 degrees. Means that theta is equals to 140 degrees divided by 2, and that should be 70 degrees. Hence, the bearing of A from C is equals to 360 minus 70 degrees, and that will be equals to 290 degrees. That's the answer. So option D is the correct answer. The bearing of Q from P is 150 degrees, and the bearing of P from R is 15 degrees. If Q and R are 24 km and 32 km respectively from P, I represent this information in a diagram. This is a wonderful question, a WACE-like question, as I can call it. This number 3, the third question. Okay, let's start. Solution. Okay, representing this on a diagram, you have to start interpreting this question sentence by sentence. The bearing of Q from P. This Q, the bearing was taken from P. So I will draw a 4 cardinal point and call that point P. For me to locate Q, you turn 150 degrees from north of P. That will give me Q. So you could draw your 4 cardinal points. Call this point P. Turn 150 degrees. Okay, 150 degrees is less than 180, so it's going to be on the second quadrant because it's more than 90 and less than 120, less than 180, sorry. So this would be 90 plus. So this point Q, I'll get it here. Draw a 4 corner point there for point Q. This is my point Q. So from here down to here is 150 degrees. Okay. And the bearing of P, sorry, this is my P. Okay, I've written it. The bearing of P from R is 15 degrees. Taking another point R, the bearing would be 15 degrees. That means P from R from P, what would you think it will be? Let me solve it here. This is the bearing of P from R. Imagine R to be here, and R, P is 15 degrees from R. So P, this is R, this is 15 degrees, and this is P. Just for instance, this is P. That means if I'm to take the bearing of R from P, I'll turn right like this, knowing that this is 15 degrees. 15 plus 180 would be 195 degrees. Therefore, that point R from P would be 195 degrees. So taking 180, this is 180, this plus another one is 270, so it's less than. So that point will be here. This point R will be on the third quadrant. So this is point R. Of course, you can see this is 15 degrees, and you can claim that here is alternate to here. This is 15 degrees also, and here remains 30 degrees to become 180. 180 minus 150, this is 0, this is 3, so here is 30 degrees to complete 180. And when we sum the two, this would be 45 degrees. And we join this to form a triangle. Join this point and this point with a ruler to form a triangle. Of course, in bearing and distance, you always form a shape, mostly triangle. On rare cases, you may get rectangle. Just know you must form a polygon, a shape bounded by straight lines. Then you use the knowledge of trigonometry to tackle it. Okay, so now add more details from the question. The bearing of Q from P is 150 and the bearing of P from R is 15 degrees. If Q and R are 24 degrees and 32 degrees respectively means the first letter takes the first dimension and the second letter takes the second distance. Sorry, first letter Q from P, is 24 degree, 24 kilometer, 24 kilometer, and the second letter Q from P is 32 degrees, 32 kilometers. Pardon me, please. Q from P, Q from P. I'm sorry. This is Q from P. Why this is R from P? Good. R from P is 32 degrees. Yeah, this is the correct one. 32 kilometer. Don't mind me. I'm talking about kilometer. That is the unit. So this is the information. They say the second question says calculate the distance of Q from R. Q from R. So I'm looking for this third distance. I'll call it X. And here my first question I is completed. I'm done with I. I've represented this information on diagram. In a diagram, sorry. So I will go to the second question. The second question I says, let me manage paper. I says calculate the distance between Q and R correct to 2 decimal places. The distance, I'm going to use cosine rule here to find R. The reason is that two sides of this triangle are known with included angle, and I'm looking for the third side, so we use cosine rule. Using cosine rule, it states that x square is equals to 32 square plus 24 square minus 2 times 32 times 24 cos 45 degrees. Okay, the using letters, it says a square is equals to b square, sorry, small letter a, small letter b, plus c square minus 2bc cos a. So taking this to be my a, I'm having it as a square equals to, taking this to be b square plus c square minus 2 in the formula times b, which is 32, times c, which is 24, cos a, cos angle opposite to the side you are looking for, and the angle opposite to my x is 45 degrees. All right, 32 square is equals to 1024. Therefore, we can say that x square is equals to 1024 plus 24 square is equals to 576 minus 2 times 32 times 24 is equals to 1536 times cos 45 degrees. This means that x square is equals to 1024 plus 576 is equals to 1600 minus 1536 times cos 45 is equals to 1086.116016. Right, everything in full. When I do the subtraction, 1600 minus 1086.116016. My answer, this means that x squared is equals to 513.883984, and therefore x is equals to square root of 513.883984. When I take the square root, this will be on approximation 22.669000933. Okay, and the question says approximate to correct to 2 decimal places. Therefore, x is approximately 22.67. This is to 2 decimal places. Okay, let me solve the third one here. The third one says find the bearing of r from q correct to the nearest degree. The bearing of r from q. Let us analyze the method to use. The bearing of r from q. Sorry, this is my r. This is my point r. Oh, I wrote it here. This is my point r, and this is my point p. I would prefer to write it here. The bearing of r from q, r, but taking the bearing from q. If I'm taking the bearing from q, starting from north, this would be from here down to this place. What would be the answer? For me to find this bearing, I know that this 30 is alternate to this 30. This is 30 degrees also, but I don't know this angle. For me to subtract the sum of this 30 and get this angle from 360, that will give me the remaining angle, the exterior angle, this angle I'm looking for, the bearing I'm looking for. Let me call this place theta and find it using sine rule. I have that using sine rule, I have that sine theta. Okay, the main formula is a sine A over A is equals to sine B over B is also equals to sine C over C. From this means that sine theta over 32 would be equals to sine 45 degrees over x. You know your actual value of x, it is on this approximation. I'm take this. So this means that sine theta is equals to 32 sine 45 degrees all over x, which is 22.669. Punch this in your calculator. 32 sine 45 divided by 22.669. This is approximately 0.99816. Sorry, let me write it here. Approximately 0.998165644, and therefore theta is equals to sine inverse of 0.998165644, and that will give me that will give me 86.529 degrees on approximation. So theta is 86.5296, and so when I sum this, theta plus 30 degrees then would be equals to 116.529 degrees. Therefore, the bearing I'm looking for, the bearing of R from Q will be equals to 360 degrees minus 116.529, which is an approximation the bearing not from theta, R from Q, and this is approximately 243.4709294, approximately to the nearest degree. It is 243 degrees. 243 degrees. That is the answer. Thank you for watching my video. Please like and subscribe. You can also share to your friends. Ask them to like and also subscribe. That's a way you can get notified of my new uploads, and YouTube can also recommend my videos. Thank you. God bless you.